In this example, we're going to look at the reciprocal function. So that's y equals 1 over x, meaning x and y are going to, well, x and y are going to be reciprocals of each other, right? So like if x is 2, then y is 1/2. Or if x is 1/2, then y is 2, right? So that's why this is considered the reciprocal function. And what is that going to look like as a graph? First thing, well, let's define reciprocal function. Maps every non-zero real number to its reciprocal. So the first thing we're going to do is consider the domain and the range. The domain x can be anything but 0. And the reason why it can't be 0 is because 1 divided by 0 is undefined. Okay? That concurrently makes the range the same, because if x can't be 0, then y also cannot be 0. Step 2 is going to be making a chart. So you have some x values that are negative, some y values that are negative. Some x values that are positive and negative, and then you get the corresponding reciprocals for the y values. Plotting those points, this is what it's going to look like. Right? It's kind of interesting, right? It's not like one curve that's connected. It's not one line. It's two separate parts to it, right? And the reason is because 0 is undefined, so you have a negative side and a positive side. So observe the graph of y equals 1 over x as it approaches positive infinity and negative infinity. As x increases, y decreases in the way that the denominator increases, right? But notice that it will never be 0, because it will, even if you go to 100,000, a million, 100 million, a billion, a trillion, whatever, it's still going to be 1 over that. It's still going to be something greater than 0. So that's why this function will never, its y value will never touch 0. So y equals 0 is considered a horizontal asymptote. An asymptote is a line that a graph approaches. Asymptotes guide the end behavior of a function. So when you go to graph something like this, when you make your curve, it's going to flatten out, right? The y value will never be 0. So as you keep going out, it will keep getting closer and closer and closer to the x-axis, but never touch it. In that way, the x-axis serves as an asymptote for this function. And then same thing going out in the negative direction. That's what you're seeing here. As this gets more and more, as the x value gets more and more negative, the y value gets increasingly bigger. So the result is you're going to have a vertical asymptote as well, right? As your y value gets bigger and bigger and bigger, your x value gets smaller and smaller and smaller, but it's never 0. And the same thing going down in this direction. So you have asymptotes, not only the horizontal one, but the vertical one as well. All right, so I don't really think you need to try this one on your own, so let's just talk it out. The difference here is you've got the function y equals 10 over x instead of 1 over x. What are the domain range and asymptotes of the function? Well, the domain range and asymptotes are going to be exactly the same as the other one. It's not, nothing is shifting up, down, left, or right. The curve is going to look a little different, but it's still going to have the same domain and range. X and y both can't be 0. All right. The only way that it would change is if you had something like y equals 10 over x, I don't know, plus 2. That would shift everything up too. That would affect the range. Not really the domain, I guess. And then I guess something that would affect the domain would be if you had something in the fraction. So that would move it to the right 3. Okay, but that's not what's happening here. So the domain and range are the same. So I'm not going to shift the gray dot at all. So yeah, the domain range and asymptotes are all the same. The function's a little different just because, all right, so you have y equals 10 over x. So just pick an x value. Like, easy one to think about is if x is 10, right? So if x is 10, that means y is equal to 1. So the ordered pair 10, 1 is going to be on this graph. So let me just get rid of that. So I move this ordered pair to 10, 1. Whoop. A little easier if I use this. Okay. So the curve is going to look like that. Same thing with a negative 10. If you substitute negative 10 in for x, 10 divided by negative 10 is negative 1. So negative 10, negative 1 is on the graph. So it would look like that. Okay. All right. We have one more example to do. Let me know if you have any questions, but let's try example 5.